This is understanding the availability features of virtual SAN. My name is Jeff Hunter. GS Khalsa is here as well, and we are going to jump right into the conversation. Now, before we get into the availability features, I think it's important to first understand a few basic virtual SAN concepts. We're going to start out with that. First of all, when it comes to a virtual SAN cluster, you can have anywhere between 2 and 64 hosts in a single cluster. So vSAN does scale nicely, again, up to 64 hosts, but you have to have at least 2. In each one of those hosts, we have anywhere between 1 and 5 disk groups. Now, each disk group consists of exactly 1 device for cache, and anywhere between 1 and 7, either solid-state devices or magnetic drives for capacity. Naturally, in an all-flash virtual SAN, all of the devices are going to be flash. You'll still have a cache and a capacity tier. Again, anywhere between 1 and 5 disk groups per host, and up to 64 hosts in a single cluster. So as you can see, vSAN can scale quite nicely. Virtual SAN is an object data store. There are generally 5 different objects that you'll commonly see on vSAN. You can see those on the slide there. When it comes to virtual machines, you're going to have a VM home. That's the VM home namespace there, that first bullet point. It's going to have files that you're probably familiar with, such as logs, the VMX file, NVRAM, and so forth. You'll find those in that VM home folder when you browse a virtual SAN data store. There's also going to be a VM swap, so that's the virtual memory swap that you commonly find whenever a virtual machine is powered on. And then, of course, the VMDKs, the virtual disks. Those are going to be objects out there as well. Each of those will be one object. You may have several objects that make up a single virtual machine. And then in some cases, for example, when you take a snapshot, you're going to see additional objects there too. So there's a delta disk and a memory delta. You'll see those types of objects too when snapshots are in use on a virtual SAN data store. Now, kind of getting a little more granular with that, each of the objects are composed of at least one or more components. So there could be multiple components that make up a single object. One thing to keep in mind as we continue through the conversation, that each component has a maximum size of 255 gig. And we'll certainly talk more about components and objects here as we continue forward. One of the more unique components you're going to see is called a witness component. And that is required for tiebreaker type situations. For example, if we have a network partition and we have a couple of sides there, so one side or the other trying to claim ownership of a particular object, the witness will be used to basically break that tie. So now each component in vSAN has a number of votes. So originally we used primary and secondary witness components. Now we use what are called votes. Each one normally has 1 vote, but if there is a need to have an odd number, which is required, of course, if you're going to break a tie, a component could have more than 1 vote. And again, we'll talk a little bit more about that here shortly. What that witness component is used for is to achieve quorum. So in other words, for a component to be active, quorum must be achieved, and we're talking about more than 50% of the components for that object being active on the vSAN data store. If the 2n plus 1 is not satisfied, so the 2 copies plus the witness is added. So in some cases you may see a witness, in other cases you might not see a witness. It just kind of depends. There's an example there toward the bottom of the screen. So again, if you're looking at a host failure, a single host failure, obviously we're going to need at least 2 data components, so that way we can survive the loss of one of those hosts. Now, since we have an even number of components there, we're going to add a witness in that situation, so that way there are a total of 3 components, which again gives us that odd number which is necessary to achieve quorum if there is some type of a partition or isolation in the vSAN environment. Okay, so we talked about a network partition just a few moments ago. Let's kind of dig into that a little bit, because that's certainly one of the scenarios where you could see failure, and it's interesting to see how vSAN deals with a network partition. So in this particular case, we've got a few screenshots here. Now, as you can see in this particular cluster, we've got 4 hosts. And you can see the yellow and red marks there indicating there is an issue in the environment. In particular, it's host number 03. So you can see that one highlighted there in the center of the screen. It also has the red exclamation point on it. If you look a little bit further over to the right-hand side, there is a column there in the disk groups area that's called Network Partition Group. And you can see we have Group 1 and Group 2. And that isolated host has created its own group since it is isolated from the rest of the vSAN cluster. So in this particular case, we've got two different groups, two partitions, in other words. Now, when we click on that particular host, we can see that all of the virtual machines have been evacuated from that particular host. It's important to note that vSphere HA is integrated with virtual SAN. So it understands that there is a network partition, an isolation there of that particular host on the vSAN network. As a footnote, it's good to understand that HA, when vSAN is enabled, utilizes that vSAN network. So in this case, with host 03 being isolated, there's no way for it to achieve quorum. It cannot have more than 50% of the votes to own any of the objects. So what has happened is vSphere HA has restarted any of the VMs that were on host 03 on other healthy hosts in that particular environment. So that's why we see that there are no VMs now running on that host 03. So again, HA rebooted those VMs. Quorum was achieved for those VMs on the other host because they have access to at least one component and the witness, as an example. So they are able to access the active components, if you will, for the objects that make up those VMs and ultimately run those virtual machines. Here's a closer look at component placement. So we grabbed one of the VMs that was running potentially on host 03. It's been rebooted, but in this case there is still a component that was left on host 03. So if you look toward the bottom of the screen there, you can see under physical displacement that there are three components that make up the VMDK, the hard disk one, in other words, for this particular virtual machine. There is a component that still is, I should say, on host 03, and then there is one that is on host 01, and then our witness is on 02. Now you can see that the component on 03 is marked as absent. And that is expected behavior. Obviously, the host is isolated at this point, so the master in the cluster that owns that particular VM does not see that other component, so therefore it's going to report it as an absent component. And after 60 minutes, it's going to rebuild that component elsewhere in the environment if host 03 does not come back online. We'll talk about rebuilds here more in just a moment. But as you can see, this is kind of a simple example of how components are placed in an environment, so that way we can avoid issues such as the failure of a single host, and in this case, a network partition or an isolation of one of the hosts in the cluster. Now, I mentioned a few moments ago the component state. I talked about how that particular component on host 03 was absent. There's a couple of ways that you might see a component marked in a vSAN environment. And one, of course, is absent, like we just talked about. The other is degraded. And there are considerable differences between the two. So one thing that vSAN is pretty good at is predicting whether a component will maybe be gone for just a little while, so a transient outage, if you will, like a network partition, for example, or if it's an actual problem with hardware, such as a failed disk or something along that line. So what vSAN does is when an object is absent, again, think about a host reboot. Maybe you're in maintenance mode, you need to reboot that host. It's going to take a few minutes to do that. Another prime example is when you pull a disk, so how you can hot swap disks in servers. This is something we see customers do all the time. They try to simulate a disk failure by simply pulling the disk out of the chassis, when in reality vSAN's a little bit smarter than that. It understands that it's possible that disk will come back. So in other words, if we just stick that disk back in the chassis, that component's going to return. So it marks that component as absent in cases like that. And then, of course, the last example on the slide there, a network partition like we just talked about. In those particular cases, vSAN actually waits for 60 minutes before it tries to rebuild that particular component or that mirror of that component on another host that's surviving in the cluster. And the reason for that is we want to minimize I/O. So we don't want to have any unnecessary I/O unless it's going to be a more permanent or semi-permanent loss. Then at that point we'll rebuild it and regain the availability, having two mirrors of that particular component, in other words. Now, when a component is marked degraded, vSAN does not expect that component to come back. So think about a failed disk. So in this case, the controller has received SCSI sense codes that indicate there is a failure of that particular drive, so permanent device loss, or PDL in other words. In that case, vSAN says, yeah, it's probably not a good chance that component's going to come back, so it will start rebuilding that component immediately, or a mirror of that component immediately, on another host in the cluster to make sure that we are protected as soon as possible against additional failures in the environment. So again, the difference between absent and degraded. Absent is when there's a good chance the component or the copy of the component will probably return, whereas degraded, vSAN is predicting that it's not going to return, so it goes ahead and creates another copy within the cluster. Now let's switch gears and talk about fault domains. That's the other important aspect we need to consider with virtual SAN. So with fault domains, it's good to understand that each host is considered an implicit fault domain. In other words, vSAN is going to spread components across fault domains, and in this case, hosts. Another option that you have with vSAN is to create larger fault domains. Many folks will take server racks, for example, and they will place hosts that are part of the same vSAN cluster across multiple server racks, and then they'll configure fault domains within vSAN that contains each of those servers. So that way, what happens here is that we are not ending up with two hosts in the same server rack having all of the necessary components. We spread the components across server racks, so that way if there is a networking or a power issue that affects the entire server rack, the virtual machine and its data remains available even if the entire server rack is lost. So that's a common use for fault domains. You can certainly use it in other ways too, but that is something that is available in vSAN that must be configured. Otherwise, each host, again, is an implicit fault domain. Now, as far as the number of fault domains needed, you need to consider how many failures that you want to be able to tolerate. A simple example here is FTT equals 1. So number of failures to tolerate equals 1. You're going to need at least 3 fault domains, so at least 3 hosts to satisfy that policy. The formula is pretty simple, just 2n plus 1. Again, that's so we have room for the 2 mirrors or the 2 replicas of that component plus a witness component. If you step up to FTT equals 2 or 3, that's going to increase, based on the formula there, to either 5 or 7 hosts. Now with erasure coding, so RAID 5.6 erasure coding, you can do FTT equals 1, which is of course RAID 5, and FTT equals 2, which is RAID 6. In this particular case, we're going to have a higher number of components, albeit smaller. That means you're going to need more fault domains. So for FTT equals 1, you're going to have at least 4 hosts or 4 server racks, 4 fault domains in other words. And of course FTT equals 2, you're going to need 6. And then an FTT equals 3 is not supported with erasure coding. You're going to have to use mirroring. Now if you do happen to assign a policy, for example here FTT equals 2, and there are only 4 healthy hosts in your cluster, you're going to get a notification like this one here. As we mentioned before, FTT equals 2 requires 5 hosts. If there's only 4 available, vSAN is going to tell you that. It's going to let you know that it cannot satisfy that policy until that 5th or additional hosts come online. Another recommendation that we have here is to take that minimum number and add at least 1 more to that. And the reason for that is so we can perform rebuilds. As we talked about a few slides ago, if a disk or a host is absent for either 60 minutes or it's degraded, which means rebuilds are going to start right away, you're going to need some place to perform that rebuild. So if you do not have any additional hosts in the cluster, so take the example on top there where I normally have 3 nodes, but I lost one of those nodes, now I'm down to 2, there's no place to rebuild that 3rd component. So think about 2 components plus a witness there, again in that simple example. Whereas if I have 4 hosts, that gives me that 3rd spot there. Even though one of my hosts are down, I have a 4th host there where I can do the rebuilds. So the recommendation there is to take that minimum number, so that 2n plus 1, and then add 1 more host to that. So that way if you do lose a host, you've got a place to perform rebuilds as well. So sometimes we get the question, why not 5 or more replicas? So if you think about FTT equals 3, that means we're going to have 4 replicas out there. Why do we not have FTT equals 4 or FTT equals 6 or 10 or something higher? So there's a lot of math on the screen. I'm not going to go into all of it. You can certainly see the numbers there. For example, the availability of just a typical magnetic disk drive is 4 nines, and then if you add some other components in there, it kind of takes you down to 3 nines. But what we get to here is the fact that at this point your odds of something bigger affecting a lot more hosts is going to happen. So power failure, a disaster of some sort, the odds of that are higher than sustaining 4 or 5 failures within the vSAN cluster there, if you just look at the math. So that's why we only go up to FTT equals 3. If you're wanting to protect against bigger failures, such as fires and natural disasters and so forth, that's obviously where vSAN stretch clusters come into play. Site Recovery Manager is another possibility there. And GS is going to cover that here in just a little bit. I want to talk about maintenance mode a little bit. Up to this point, we've talked about unplanned downtime. We need to address planned downtime as well, and that's exactly what maintenance mode is for. So when you have a host that goes into maintenance mode, or when you basically configure a host to go into maintenance mode, and you have vSAN enabled in the cluster, you're going to be asked for what data migration option that you want to use. And there are three. There is ensure accessibility, there's full data migration, and no data migration. So instead of making you read the small text that's in the little help balloon there, let's take a look at a few examples. So here we have a basic 4-node vSAN cluster, and for simplicity's sake, I've only got a couple of objects here. So I've got a couple of VMDK files. I have one that has FTT equals 1 assigned to it, and I have another that has FTT equals 0 assigned to it. Now, when the cluster is healthy, in other words, when all 4 nodes are online, both of these objects are accessible, right? So no issues there. But for maintenance mode, there are other considerations. So let's take a look at each of the 3 possible options and see how they affect the placement of these particular objects here. So we put host number 1 into maintenance mode. And in this case, we selected the default, so ensure accessibility. So in other words, vSAN is going to say, okay, I'm going to make sure there's at least one replica out there that's accessible and active, so that way the VMs don't go offline, even though we're putting this host in the maintenance mode. So what happens is it's going to not move that second replica of the green object, if you will. However, since there's only one copy of the orange object, it's going to go ahead and move that to another host in the cluster, again, to make sure that both objects are accessible. So in other words, we are ensuring accessibility. Now the level of availability is slightly degraded for the green object because we only have one replica now instead of 2. But again, we can still access that as long as we don't lose any other hosts in the environment. The advantage of using ensure accessibility gives you the balance of availability and minimizing the amount of data that you need to migrate. So again, that's the reason that's the default there. Kind of gives you the best of both worlds, or at least a reasonable balance between both. Again, making sure that components stay available, but at the same time minimizing how much data we have to move as part of going into maintenance mode. So let's take a look at the next option, which is full data migration. This is pretty self-explanatory. In other words, we're just simply going to evacuate all of the data off of that host before we go into maintenance mode. One thing I forgot to mention previously is normally when you use the ensure accessibility option, typically that is for shorter term planned downtime. So again, a host reboot of some sort, maybe you're doing some patching, a firmware upgrade, things along those lines where the host is only going to be down for maybe several minutes or a half hour, something like that, and then it'll be back online. Now, full data migration is for a longer period of planned downtime, or in some cases where a host is going to be permanently removed. So we want to evacuate all of the data off and make sure that those objects remain highly available. So as you can see on the screen here, what happened is it's going to move both of those components to other hosts in the cluster. So the green component, or the green object I should say, has both of its replicas plus the witness, and then of course the orange object with FTT equals 0 just has that single replica there, but it is also moved so that way accessibility is maintained. The last option to consider is no data migration, and normally this is not a big deal to worry about unless you do have objects that have FTT equals 0. So in other words, objects with only one replica, because depending on where that component sits in the environment, if you put a host in maintenance mode, you don't do any data migration, and the only copy of that component is on the host that is going into maintenance mode. As you would expect, that component will no longer be available. Where this might be useful is if it's okay for objects with FTT equals 0 to be down for a little while. If that's the case, then no problem. The other place, and probably more commonly where you're going to see this, is you don't have any objects in the vSAN environment with FTT equals 0. Everything is FTT equals 1 or higher. And in that case, no data migration would be fine because we would still have at least one copy, or one replica, if you will, of that component on another host in the environment. So again, 3 options here. No data migration is going to be the fastest. So if it's just a quick reboot and it's okay to have downtime for a few objects or whatever that have FTT equals 0, then no data migration is perfectly acceptable for that. Another thing I'll just mention and touch on here real briefly is just drive and host failure. There's a couple things to keep in mind when it comes to that. First and foremost, I want to talk about drive degradation. So what's cool about vSAN is that it has the ability to detect issues in the environment. So in vSAN 6.1, for example, if vSAN observed long periods of high latency, in other words, if over a 10-minute period or so, it would see high latency for a single disk, it would actually unmount that disk, or even potentially the disk group if it was the cache device that was causing issues. So that's nice there, because then what would happen is the lack of performance from that particular disk or disk group then would be avoided. But the problem with that is we only looked over a 10-minute period, which in some cases could produce some false positives. So vSAN 6.2 was engineered a little bit further to be more intelligent. First thing I'll point out is that 6.2 will not unmount a device due to excessive read latency. Also, if we're looking at the cache device, the cache tier in other words, we're not going to see unmount due to excessive write latency there either. Now, there is a way to override that if you need to. Some folks may want that behavior. So if that's the case, let's say you have multiple disk groups in the environment and you're okay with losing a disk group due to issues like that where performance is top of mind or most important. You can change that via the command line there, that ESXconfig advanced config option there. So what vSAN 6.2 also does is it looks at more than one interval of time, so more than one 10-minute interval. These are randomly selected. If it detects latency in all of those 10-minute intervals there, then obviously there is a permanent issue with that disk, or most likely a permanent issue with that disk. And at that point, that's where vSAN is going to unmount that and no longer use that disk to avoid the performance hit there. One other thing it'll try to do is remount any unhealthy disk. So maybe it's a transient issue with that particular disk and things are okay after a while. And if that's the case, vSAN will try to remount that. And if successful, will continue to use it then. Again, it tries over a 24-hour period before permanently marking that device offline. You can see evidence of this in a few different logs out there. The vmkernel.log will show that. The host log as well, and you can even see some events in vCenter. So if you're thinking that might be an issue, check those spots there for some of the text that I'm showing on the screen. The last item I'll mention before turning it over to GS is drive failure with deduplication and compression. So dedupe and compression disabled. If you lose a capacity drive, just that drive is going to be unmounted. The exception there would be if you only have one capacity drive, which is certainly a possible configuration. It's possible to have a disk group with one cache device and one capacity device. Needless to say, if you lose either one of those, then that whole disk group is going to go offline. If the cache device fails, of course, then the entire disk group is unmounted, regardless of the number of capacity devices that you have. Now, if deduplication and compression are enabled, due to the way that data is laid out on the capacity drives being deduped and compressed, if we lose any one of those drives, whether it's the cache device or any of the capacity devices, then the entire disk group is unmounted in that case, because there's no way to selectively pick just one disk, as it may have the single copy of that deduped data on that particular disk right there. So, and now I'm going to turn things over to GS.
Thank you very much, Jeff. Now we're going to get into talking about stretch clusters and failure scenarios. So first off, what is a vSAN stretch cluster? The idea of a vSAN stretch cluster is we're talking about active data centers, and our VMs can run at either of those sites. We can vMotion VMs between those two sites because we have that storage stretched between the two. We have zero data loss if we lose one of those sites, and we have a really low RTO in the case of recovery. I'm not going to get into a lot of the detail of how to set up and configure, or the specific details around managing and maintaining things like that around stretch clusters. That's going to be covered in other sessions. What I'm going to focus on specifically today is virtual SAN stretch clusters and how that relates to availability. So first off, we've got the same idea of fault domains with stretch clusters. Virtual SAN is based on this idea of fault domains. That carries over to stretch clusters, and it's really an extension of that. We treat each of the two sites as a fault domain. Now, the next question you're probably asking is, now wait a minute, you told us that we needed 3 fault domains in order for virtual SAN to work. And that is correct, or at least 3. We need that odd number. That's correct. And the way that we handle that is we have this third fault domain that we call the witness. Now in this case, this is not just a witness component. This is actually a witness appliance. And that's a virtual ESXi VM that would run at a third site, be connected to your two sites that contain data, and that witness appliance is just going to contain metadata. And it's just going to act as that third component, the tiebreaker. We'll get into some failure scenarios, and you can see exactly how it fits in, but that's what acts as that third fault domain. How do we maintain communication between those sites? How do we define failure? We do that utilizing a heartbeat, and that heartbeat is sent out every second between all these different components, and the loss of 5 heartbeats in a row will trigger a failure. We talked before about this idea of quorum, and in a stretched situation you have a new concept of preferred and non-preferred. The idea here is that preferred and non-preferred really just comes into play if both of our data sites are functional, they're both up and running, but communication between the two of them has been severed, and where they're still both communicating to that witness appliance. And we need to decide which one is going to, where that VM is going to run. And in the case of a preferred and non-preferred site, the idea of that is that those VMs would end up running at that preferred site. We would establish quorum between the witness appliance and the preferred site. And I'll talk a little bit more in detail about that a little later. From a recovery standpoint, how do we handle that with virtual SAN stretch cluster? What we're using there is we're utilizing the same mechanism that we use in a regular vSphere cluster, which is HA. So if a site goes down, we're going to recover the VMs that we're running at that site at our other site using vSphere HA. So let's start talking a little bit more in detail about how do we lay out components when it comes to stretch clusters. So you can see here we're talking about just a single VM running at our preferred site. And then we have our non-preferred site, and we've got our witness. So of course, one of the copies of data is going to be at that preferred site. And since we're talking about vSAN, that copy of data doesn't have to be on the host that VM is running on. In this case, we've got that VMDK running on a different host from the host that the VM is running on. Now, the copy of that VM is at our second fault domain or our second site. So we've got that other VMDK running at the non-preferred site. And lastly, we have that witness component. And that witness component is obviously running at our witness site. So this should look really familiar to what Jeff was talking about before when it came to how things are laid out from vSAN components in a fault domain scenario. Looking at host or network failure. So we've got our same situation. What happens if we lose that host that the disk was running on for this VM at our preferred site? And what's going to happen is, in the short term, from the VM standpoint, nothing really is going to change. The VM is going to continue running, and it's going to be running on that disk that is now located at the non-preferred site, even though the VM is still located at our preferred site. And depending on what kind of failure we're dealing with, depending on if we expect that host to come back quickly, if the host was just network isolated, we may wait that 60 minutes before we start rebuilding those components, or we may start rebuilding them right away. Just depends a little bit on what the specific scenario is. But we're going to start getting those components back, start building those components back, get that VMDK deployed onto another host, and we're back to operating again with 2 copies of our data. So how do we handle something like a disk failure? In the case of disk failure, not the entire host, just one of the components in one of a host, it's going to be somewhat similar, where the VM is going to continue to operate, no interruption, just going to operate off of the disk that's at the non-preferred site. We start rebuilding that component on another host or in another disk group, and as soon as we've got that data copied, rebuilt, copied back over, we're back to normal operations from an availability standpoint. One other thing I wanted to point out, I didn't highlight here what happens if we lost the host that the VM is running on. In that case, if we lose the host that the VM is running on, we're just going to use HA to recover that VM onto another host at the preferred site. And then again, we're back up and running. So now let's talk a little bit more about site failures or site partition events. So what happens if we have either a complete network partition, where we lost all network connectivity to a site, in this case our non-preferred site, or the site itself fails for some reason? From an availability standpoint, both of those situations are basically the same. So what we're going to do is, those VMs are obviously going to get shut down as part of that. Now, if the site is just gone, had a power failure or something like that, the VMs are going to power off as part of that. If it's isolated as part of an event, HA is actually going to power off those VMs as part of its isolation response. And then what we're going to do is HA is just going to restart those VMs at our other sites. From a component standpoint, from a failure domain standpoint, the preferred site is still able to communicate with the witness, so we have that majority of components that are still able to communicate. We bring those VMs up at the preferred site, and you're back up and running. What happens if you have a preferred site failure or partition? So, similar scenario, we either lose that preferred site or the preferred site becomes network isolated. It's the exact same response. We're going to HA restart those VMs at our non-preferred site, and we're back up and running. What happens if that link, just the link between the preferred and non-preferred sites, goes down? Now in this case, this is where that preferred, non-preferred idea comes into play. The witness is going to create quorum with the preferred site, will power off the VMs at the non-preferred site, and power them on at the preferred site. And then, again, everything is back up and running. What happens if we have a network failure just between a data site and a witness? So we just lose, say we just lose this connection. So the thing that's going to happen here is nothing from a VM standpoint. Your VMs are going to continue to operate just as they had before. No impact to the operation of your VMs. What we're going to do is we're going to, in this case, fail that witness. So we're going to decide, okay, one of our sites can't talk to the witness. Our two sites can still talk to each other. We're going to decide to fail that witness. Now, if you can recover that witness within a short amount of time, that's great. The other option is you can just deploy another witness. These witnesses are an OVA file. You can spin them up really quick. Once you get that new witness spun up, we're going to resync that metadata, and everything is back to normal, back to the way that it was, and your VMs are completely non-disrupted by that process. Because again, when we fail that witness appliance, the preferred and non-preferred sites create quorum between the two of them. So another scenario, what happens if we lose our witness? What happens, the site gets disconnected, or for whatever reason that witness fails? Really, it's very similar to the situation that we just talked about before. Your VM operations continue as normal. No impact to your VMs. The two sites that contain data create quorum between the two of them. VMs that we're running at each of those sites are not disrupted. All we would need to do is either recover that witness or deploy a new one. We resync, again, our metadata, and we're back to normal operations. So that covered stretch clusters from an availability standpoint. The next, and really the last thing that I want to cover, is talking about backing up virtual SAN, replicating VMs on virtual SAN, and disaster recovery with virtual SAN. Kind of get into all three of those things. So the first thing that we'll talk about is backup. And the big thing that I just want to point out with backup is, if you're using VADP right now to do your backups, the VMware APIs for data protection, if your backup tool is using those, it's going to work with vSAN. vSAN supports VADP. I would check with your backup vendor just to verify and confirm, but there isn't a good reason why it wouldn't work with vSAN. The other thing is, if you haven't looked at it and you need a backup product, or maybe your backup solution for whatever reason doesn't support it, something along those lines, you can use VDP. VDP is something that's fully supported with vSAN. It's integrated, interoperates with vSAN, and just makes for a really nice, simple, basic use case. One thing that I will point out, and I just want to emphasize with vSAN, is replicating your backups. It's usually not a good idea to store your only copy of backups on your primary storage. So if you're backing up to your VMs that are running on a vSAN, if you're storing your backups on that same vSAN, you'll want to get those replicated somewhere else as well. Now, there is a good use case for keeping those VMs on that local vSAN as well. So backing them up locally and replicating them is good to get them off-site, but having a copy of them locally makes for faster restores if you're just restoring a single VM or a single file or things like that. Next, let's talk about replication. So the best and simplest, easiest option to use is vSphere replication. vSphere replication is included in Essentials Plus licensing and higher. It's VM-level replication. It supports policy-based replication. You can configure and utilize policies as part of using vSphere replication. I want to point out, because it's a somewhat common misunderstanding, is vSphere replication uses a lightweight delta method for tracking changes and getting those sent across to the other site. It's not using snapshots. So important consideration. There is a way for vSphere replication to use snapshots, but that's specific to if you're using application consistency as part of vSphere replication. By default, vSphere replication does not use VM snapshots. One really cool thing with vSphere replication and vSAN is those two together, vSphere replication 6.0 or 6.1 and vSAN 6.1 or 6.2 support a 5-minute RPO, as low as a 5-minute RPO when it comes to replication. So really nice option there from an availability standpoint. I will point out that with vSphere replication, folder organization becomes important when you're talking about vSAN. Because vSAN just has that single data store that we present up, folder organization can become more important. And a really simple way to deal with that is at your target site to just create a folder where you store those replicated VMs. And that will just make your folder organization a little bit simpler. One other option that I do want to point out is EMC's recover point for VM. If you need less than a 5-minute RPO, recover point for VM may be something that you want to take a look at. I would point out that more often than not, if you need less than a 5-minute RPO, you probably want to look at some kind of application level availability rather than using a VM or OS level replication. Just a thought. Recover point for VM, I believe there are some licenses for that included if you purchase a VxRail. It's something that's not normally included, though, it is not included in any kind of VMware licensing. From a disaster recovery standpoint, what are we looking at? Really, the best solution from a disaster recovery standpoint would be vSphere Site Recovery Manager, SRM. What SRM is going to give you is it's going to replicate your VMs to utilize vSphere replication from a VM replication standpoint, and provide disaster recovery orchestration, automation, and non-disruptive testing for your environment. And it's fully integrated and interops extremely well with virtual SAN. The one thing that I do want to note is from a placeholder data store standpoint, talking about vSphere replication, I mentioned how you organize your folders, that's important. It becomes even more important with SRM because we're going to create those placeholder VMs at the recovery site, and really it's not going to cause you any kind of a recovery issue or problem. It's just going to make your folder organization and finding what folder a VM is in a little bit harder if you don't plan it out beforehand. But again, there's no impact it's not going to change how recovery happens or anything like that. So now I'm going to demonstrate running a recovery plan in Site Recovery Manager from a protected site that's using vSAN to a recovery site that's also using vSAN. And of course, we're using vSphere replication to replicate those two. So we've triggered running the recovery plan. We're going to change the recovery type to disaster recovery. And you can see that we're protecting from our Palo Alto site, recovering at our Wenatchee site, and we're recovering 100 VMs. You can see how few clicks it took to get the recovery plan started. This shows the simplicity of running a recovery plan with SRM. You can see the steps that it's walking through. We've sped it up just so that you don't have to watch the entire length of this recovery plan. And you can see those steps are now complete. Recovery is finished. I'm going to show you our VMs running at our Wenatchee site. All 100 of them have been recovered and are powered on. Lastly, I just want to highlight how fast that recovery plan run. Looking at the report, we can see that it only took 10 minutes and 58 seconds.
We just literally failed over 100 VMs running on vSAN in Palo Alto on an all-flash vSAN cluster, by the way. Failed those over 800 miles away to the all-flash vSAN cluster in Wenatchee in 10 minutes and 58 seconds. Is that what we just saw?
That's exactly what we just saw. And I think both of us were equally impressed when we first saw that recording. So I think our audience is going to enjoy that as well.
Yeah, certainly. It demonstrates a couple of things, right? It just demonstrates the performance that vSAN has, the ability to recover those virtual machines and boot those up in less than 11 minutes. But then it also shows the automation power of Site Recovery Manager too. So when you couple those two together for disaster recovery, it doesn't get any better than that. So great demo. Nice work.
The other thing that I think it highlights really well is the simplicity of SRM from a recovery standpoint. And when you combine that with vSAN, just what a nice combination that makes.
Yep, for sure. Good stuff. So we're at the end of the presentation here. So just to recap a little bit, we'll take a moment here and just kind of cover what we already hit in detail. Just a reminder, we hit the essential concepts of vSAN. So understanding what each of the objects are. So vSAN is an object data store. Each of the pieces that make up a virtual machine. So for example, the VM home that has like the VMX file and logs and NVRAM and those kinds of things, that's an object on vSAN. Obviously, individual virtual disks are an object on vSAN. And then each of those objects are made up of at least one component. But then we spread those components. We have replicas or mirrors of those components, and we spread those across fault domains. So that way we can survive, host failures, disk failures, and we can even have multiple copies out there. So for example, FTT equals 2, we could literally survive the loss of 2 hosts, and that virtual machine data would still be available. There's a couple of ways we can store those components out there too. We can do RAID 1 mirroring like I just talked about. We've also got RAID 5 and RAID 6 erasure coding. And then with fault domains, I think the key thing to point out there is each host is an implicit fault domain. So without changing any settings, vSAN is going to treat each individual host as its own fault domain. Another thing you can do with fault domains is actually spread components across server racks. So that would add an additional level of resiliency against things such as a rack power failure or a top of rack switch going out where you lose network connectivity for the entire rack. So you can configure those fault domains in vSAN, which again makes it a very resilient platform for running all types of workloads, desktops, business critical applications, disaster recovery like we talked about, so lots of use cases for vSAN. And then I also wanted to touch real quick again on planned downtime, so that's maintenance mode. We have options there too, so vSAN is robust in the fact that it gives you options on how you want to move data around when you put a host into maintenance mode. For example, if you're just going to reboot a host, you can just ensure accessibility. That makes sure that the host or the data stays online for a particular object, so the level of availability might be reduced, but it will still be available in the cluster if we just use the default setting, which is ensure availability. We've also got the option to migrate all of the data off, so evacuate all data if we're going to decommission a host or it's going to be offline for a longer period of time. And then if you really just need to put a host in maintenance mode very quickly, you have the option to not migrate any data. Anyway, that's kind of the stuff that I covered there, GS. If you want to take a moment or two and just kind of recap what you talked about, and we'll bring this session to a close then.
Yeah, sounds good. So the main thing that I focused on is talking about stretch clusters and stretch cluster failure scenarios. So we talked, first off, kind of walking through what Jeff talked about in a normal vSAN. We talked about a stretch cluster situation where you have drive and host failures. And really in a lot of exactly the same thing that happens in a normal vSAN. You have those failures. We've got the multiple copies of the information. The VM uptime is preserved as much as possible, depending on the different situations, and we recover that data quickly. The things that are really unique to stretch clusters, we also talked about, where we looked at different failure scenarios in terms of having links go down or sites go down or losing the witness. We talked about preferred and non-preferred sites and how those fit into decisions that are made as far as what systems stay up and go down if you have a split brain or a similar scenario. And then we also talked a lot at the beginning about fault domains. So the whole idea of the stretch cluster is really based on that fault domain concept. And we just build on that to create that stretch cluster availability. And then lastly, the thing that we focused on is looking at, from a holistic availability standpoint for vSAN, we talked about backing up the VMs that are on your vSAN. We talked about replicating those VMs, and then we talked about disaster recovery and what that looks like.